Assalamu alaikum. I'm here with the revision topic of data transmission, chapter number 2. What you have to study here is the first that you need to study here is data packets. And you can see for yourself, then you have to study the packet switching, the concept of packet switching, and then methods of error detection, as well as the method of data transmission. Be very cautious about them. And the last thing is your encryption. So these are the topics that you have to cover in chapter number 2. Let's start from chapter number 2. The beginning is from data packets. What you need to remember is data packets can also be called datagram. And it is basically composed of 3 components. These are this packet structure should be very well embedded in your memory. What you need to remember is the packet structure is the beginning is with your header. The second one is your payload, and third one is your trailer. And header is further divided into something that it contains. The first thing is IP address of the sender, or IP address of the receiver, of the destination, sequence number of the packet, because it needs to be because it needs to know that it was what is the sequence number, and then size of the packet as well, that is in bytes. Payload is basically the data itself, that is 64 KB normally, and then you have the trailer that contains the method of identifying the end of the packet, and some sort of error detection technique is there, and that is further explained in the subsequent material. Packet header is the same, IP address of the sender, IP address of the receiver, the sequence number of the packet, and this is needed to ensure all packets can be reassembled into the correct order. And that is why the packets are numbered as well. The last thing is your packet size, and this is also needed to ensure that the packet is going to be containing the same number of bytes. And then they have arrived intact as well. Your payload consists of the same 64 KB data. And then lastly, we have the packet trailer. And in this, we can talk about the term cyclic redundancy check CRC. And that is basically explained as the adding up all the 1 bits in the payload and finding out the hex value of that value. And that results in your CRC being computed. And why is it needed? To ensure the data is being transmitted accurately by the sender. And then again, CRC is recomputed on the receiver's end to ensure that data has been received accurately or not. Packet switching. As you can see, the packet switching concept is mentioned here because the packets are not going to be following the same route. The concept of router is going to be used here. And router is an intelligent device that knows the best possible path to reach the destination. So packet switching is a method that is used in order to ensure that packets that are divided into subparts are reaching the destination accurately. And each packet can be sent independently from the beginning to the end. It may happen that some packets are arriving out of order as well, and that is why the need of your identification of the sequence number is important, because it may happen the packet that was sent in the beginning had arrived in the end, or vice versa, it may happen. So that is why you can see for yourself that on the receiver's end, this packet is going to be reassembled once again. Now you can see that it is the 5 packets have been sent. Each packet will follow its own path or route. Routers will determine the route of each packet. Routing selection depends upon the number of packets waiting to be processed. The shortest possible path is always selected. And unfortunately, packets can reach the destination in a different order. So that's just one thing that you need to remember is the packets may reach out of order as well. After that, what you need to know is the method of error detection, the data transmission, very important thing, the direction transmission. That can be one direction that is called simplex, and 2 directions, which is duplex, further classified into half or full. Then we have the method of transmission that can be how many bits are being transmitted. If it's 1 bit at a time over a single wire, that means it is serial transmission. Multiple bits are transmitted over several wires, that will be treated as your parallel transmission. Thirdly, we need to take into account the synchronization, that is how to ensure that data is going to be received in the correct order. They will be synchronized, they will be reaching not out of order, they will be all reaching their destination properly. Simplex is defined as 1 direction only, and from sender or to receiver, and the example is from computer to a printer. So simple example is, all the other examples from real life are also there, like loudspeaker and television and other stuff. But one thing that you need to see with respect to computer is example will be sending from a computer to a printer. Then we have half duplex, which is both directions but not simultaneous at the same time. And you can see the example is very simple, the walkie-talkie, because in walkie-talkie, if one person is speaking, then the other person waits for the conversation to end, and only then the second person starts speaking. And that is half duplex because you cannot perform this both direction at the same time. On the contrary, full duplex is dealing with both directions at the same time, and the best example of it will be the broadband internet connection. Because in this, you can see that the data is sent and received at the same time, and that is why it is the example of your full duplex transmission. After that, we have the method that we need to know that can be your serial, that is 1 bit at a time. Types of data transmission can be serial or parallel. Serial is, you can see, single wire is being used and 1 bit is sent over a single wire. And you can see for yourself, looking at the example, it is definitely going to be less costly because 1 wire is being used. It will be secure because the data will not be skewed. But on the contrary, this method is going to be time consuming. And USB is the best example to talk about because the letter S itself is representing the serial transmission. So USB is the best example to talk about the serial transmission. On the contrary, if I talk about the parallel transmission, you can see several bits of data are transferred, usually 1 byte. It can be 16 bits or it can be 24 bits as well. But normally it's 1 byte that is being sent over several channels. And then you can see for yourself that parallel transmission is feasible for smaller distances. Parallel transmission is costlier because it is using more channels and the data can be skewed. But the fastest transmission that is needed for shorter you can say distance, that is the best example. Like for example, the internal components of the computer, the internal circuits in a computer are definitely using parallel transmission because they need to do the work faster. The distance traveled is very short and high speed transmission is essential when it comes to the transmission that is happening inside the computer system. Now you can see for yourself the examples, the activities that are being done here, and the past paper questions are definitely going to benefit you in order to prepare this material. Along with that, the definition and the differences, that comparison is also very important. So you can go through the same as I talked about. Less risk is being involved, more reliable transmission because of over longer distances, a serial. Transmitted bits won't have the risk of being skewed. Use of the amount of data being sent is relatively small. Used to send data over long distances, for example, telephone wires, and less expensive, as I talked about, because 1 wire is being used. On the contrary, parallel, faster rate of transmission works well over shorter distances. Since several channels are being used, the bits can arrive out of, the bits can be skewed. Preferred method when speed is important, and if data is time sensitive, parallel is the most important method for data transmission. Parallel requires more hardware, making them more expensive, easy to program, input-output operations when parallel is being used. So there are certain things that you need to remember if it comes to the comparison of serial and parallel. The next important topic is USB, Universal Serial Bus. What you need to know in this is the use of USB in nearly all the devices, and that is going to be making it a plug and play. And you can see for yourself, the moment I connect a new device to the USB port, it is automatically detected because the device driver is searched and installed automatically. On the contrary, if I do not have the USB port, as was the norm earlier, I had to install the device driver myself. But nowadays, the life is becoming very easy because of the use of USB port. After that, you need to see the benefits and the drawbacks. Very quickly, I am reading them for your own benefit. The very first one is devices plugged into the computer are automatically detected and the device drivers are automatically loaded up. The one that I discussed right now. Connections can only fit one way, although USB-C is going to be discussed later. But it is also an advantage that results in preventing the incorrect connections being made. It has become an industry standard. It means considerable support is available, can support different data transmission rates. From 1.5 megabits per second to 5 gigabits per second. You can see for yourself, it's small b, that means it is bits per second. No need for external power source since cables are supplying plus 5 volts of power. USB protocol notifies the transmitter to retransmit the data if the errors are detected. This leads to error-free data transmission. So this is something that you need to see. USB protocol is going to work on error detection. So if the data is not transmitted, so it will definitely be raising this concern, and you will be getting the error-free transmission. Relatively easy to add more USB ports if needed because of the use of USB hubs. USB is a backward compatible, that is older versions are still supported. On the contrary, the drawbacks are standard USBs only support a maximum cable length of 5 meters. Beyond that, USB hubs are needed to extend the cable length. 5 meters is the cable length allowed, maximum cable length allowed. Even though USB is backward compatible, very early USB standards, version 1 may not be supported anymore. By the latest computer systems, even the latest version 3 and version 4, USB-C systems have a data transfer rate which is slower compared to, for example, Ethernet connections. And this Ethernet connection is not in your syllabus. You will study, inshallah, in the A levels. But that is also mentioned here for your own benefit. Although the USB is being discussed here, but then we have a USB-C that is becoming very common. And this is a 24-pin symmetrical connector, which means it will fit either way around and is much smaller and thinner than the older USB connectors. After that, you can actually attempt all these activities that will benefit you in preparing well for your paper. Then methods of error detection, very, very important. And in this, you need to know the methods, you need to know how to apply those methods, and you need to know how to answer them. The very first method is parity check. The second method is your checksum. Please remember, the method is parity check. The second method is checksum, and the third method is echo check. In this, what you need to know, how did you find out the parity? Fine, you may be asked to explain how did you calculate, how did you find the value for even parity setting or odd parity setting? And for that, what you need to actually remember is this MSB, this 8th bit that we have learned is going to be stored as a parity. The parity value, and can be a 0 or a 1, and it depends upon the parity setting. For example, assume that you were asked to perform even parity. Iska matlab, it will actually find out in this byte the number of ones. The number of ones, as you can see here in this example, is 1, 2, 3, 4. And since 4 is an even number, that's why it will add a 0 here, because the number of on bit is already an even number. On the contrary, if you are sending the data that is maybe something different, like for example, if I just assume that I am sending the data as 1 and then zeros are there. So definitely in this case, the number of ones is 1, which is an odd number. So in that case, what will happen is we'll be adding a 1 to make it become an even number of ones here. On the contrary, the setting was odd. So what will happen is you will actually be adding up all the ones here, and the number of on bits is going to be, in this case, for example, if I'm talking about this example, it's going to be like, if assume that I was asked to go with the odd parity setting, and you can see the number of on bits are 1, 2, 3, 4. And since 4 is not an odd number, that is why I have to add a 1 here to make it become odd. So the number of ones should be odd in your odd parity. If not 1, add a 1. Agar already odd number of ones honge, means agar aapke number of ones ki taadad 1, 3, 5 या 7 hogi, so you will be adding a 0 there. But if the number of ones ki taadad jo hai wo even number की तादाद होगी तो आप उसमें 1 add करोगे. I think the rule is very simple. So you can practice from the past papers, you can practice the activity, and that will make your work a little better. A problem with parity is if 2 bits have swapped their positions, like if 2 bits have changed their positions, so you can see for yourself the parity will still be the same. So in that case, what you will be doing is you will be not working with parity, you will be working with a parity byte. As you can see here, and sometimes we are being asked to work apart with the parity byte. In this case, what you do is you are sometimes asked to find out the parity, the byte number or the bit number that has a problem, or sometimes you are even asked to explain how did you find out this answer. So in this case, what I did was I first of all worked horizontally to find out the error byte, the byte that has an error. Then I worked on bitwise and found that where the error is. And in this manner, the intersection told me where the error is. And in this manner, I was able to find out the position that has an error. So you can practice this question, simple, very simple. Method is the same, that you apply the work byte-wise and then you apply the work bit-wise, and then the problem area is identified, the bit is identified, and that bit is going to be corrected to make the transmission successful. Next topic is checksum, very important. What you need to remember is checksum is actually applied on a block of data. It is performed on the sender's end. The same checksum is sent along with the data to the receiver. The calculation is done once again on the receiver's end. The 2 checksum values are being matched. If the 2 checksums are equal, it means that the data is accurately sent. But if the 2 checksums are not matching, it means that that particular packet will only be resent, will only be asked to be resent, not the entire file will be resent. So it's very simple. Then what you need to know is the process, very simple method. As we do in real life also, the same method is being discussed here. Echo check, as you can see, echo is means that you are going to send the data and you are going to send the data back to the receiver. So you can see with echo check, you can see the data is sent to another device, the data is sent back to the sender, and then the sender is going to compare the two sets of data to check if any error has occurred during transmission. But the problem with echo check is I cannot be sure that whether the error occurred when the data was sent or whether the error occurred when the data was received. And that is why it is not a very preferred method. You can see for yourself, the method is written here. You can be asked even to reorder this checksum method or the echo check method as well in your paper. So this is something that you need to see, that what is echo check, a copy of the data is sent back to the sender. The data returned, it is compared with the original data. If there is no difference, then data was sent without error. If there was a difference, then error had occurred, and definitely it results in retransmission of the data. And then we have check digit calculation. Check digit, what you need to know is what is check digit. And what you need to know here is in which scenarios is check digit going to detect the errors. The 4 scenarios, incorrect digit is being entered. Any example you can mention, but the example should be actually something that is going to be going with the definition that incorrect digit is being entered. Transposition error, where 2 numbers have swapped their positions. Omitted digit or extra digit is being added, and phonetic errors, like for example, it's not heard properly. So instead of example 13 instead of 30. Remember, one thing is you don't need to learn this method algorithm at all. The method will be given to you, and what you need to follow is you need to follow the method very religiously. Just follow whatever is written there, and then you are going to get the right answer. And you need to know that you can sometimes be asked to verify that what your answer is. So in both scenarios, you can get the right answer possible. Now, moving further, we have ARQ. Again, ARQ is going to be automatic repeat request. It's a method that is applied to ensure the data is being transmitted accurately. It uses positive and negative acknowledgements. And what are acknowledgements? Messages sent to the receiver indicating the data has been received correctly or not. A timeout, and please remember, timeout is the time interval allowed to elapse before an acknowledgement is being received. The receiving device is going to perform the same. You can see the same. The receiving device receives an error detection code as part of the transmission. Normally, it's CRC. If no error is detected, a positive acknowledgement is being sent. However, if an error is detected, then the receiving device now sends a negative acknowledgement, like you do. Like, for example, if you're able to understand, you say a nod, yes, we have understood. And if you don't understand, then you say, no, I need a recap, or I need a revision. So similarly, here also the same thing happens, that we have a negative acknowledgement or a positive acknowledgement. And if no acknowledgement is being sent or received, iska matlab kya hua? It automatically resends that data until a positive acknowledgement is received. Like, for example, I delivered a topic, so I will wait for the acknowledgement. If you don't send me the acknowledgement, I am going to retry to send you the data once again. And that will be the same thing happening here as well. Or until a predetermined number of retransmission has taken place, but that may happen. I kept on sending and sending and sending, and you don't give me the acknowledgement. And definitely, I'm going to wait for a certain time period, and then I'll go with my lecture. Same case goes here. You have to go with a predetermined number of transmission to be taking place if no acknowledgement is being received. Lastly, but very important, is encryption. What you need to remember is encryption will not stop the hackers at all. Still, the hackers will be able to intercept the data, but the hackers will not be able to know what the error is. They will only be what the data is, because they will be able to intercept, but will not be able to know, because the data is in ciphertext. So what you need to know is, one thing is hackers, if intercepting the data being encrypted, still they will not be able to understand what the message is. Secondly, you need to know the terms plain text and ciphertext. Plain text is before transmission, before encryption is being done, and cipher is after encryption is being done. Encrypted text is called the ciphertext. And then we have symmetric and asymmetric encryption. Symmetric is something that can be easily detected, because this is dealing with the key that is being used to encrypt and decrypt the message. And you can see for yourself, this one is just an example given to you, that you can see for yourself that it was told that COM, like this was the mechanism, 42913628856, 42913628856. So what happens is, C is actually going 4 places ahead, and what makes it a G, because D, E, C. See, after C is going to be D, E, F, and then G is going to be the fourth letter. O is going to undergo 2. It means O. After that, it will be P, Q. So you can see that Q is written here. Then similarly, M is undergoing 9. So you can see M is becoming V. Then P undergoing 1, it becomes Q. U undergoing 3, it becomes X. T undergoing 6, it becomes a Z. E undergoing 2, it becomes a G. R undergoing 8 becomes a Z. And S undergoing 5 becomes X. And C undergoing 6 becomes I. In this manner, this is completing this encryption key, and then it is recontinuing with the other values. This one is not a very secure method because of the reason that it can be detected, it can be intercepted, and the hacker can be able to decrypt this message because it is not very much secure. On the contrary, if I talk about asymmetric encryption, that deals with the concept of public and private key. Public key is available to everybody, and the private key is only known to the computer user. And definitely the data will be decrypted using the private key, and since it is available only to the person who has the keys, only that it is right, it will be more efficient, it will be more secure as compared to the symmetric encryption. And you can get a question with this in your paper that deals with this topic, that you are given this sort of thing, and you are asked to either encrypt or decrypt the message. Be very clear. If, for example, I talk about this question, I was given this data that was the ciphertext, and I was asked to convert this into this one. So I'll do the reverse thing. Like, for example, from G, I'll go -4 and I'll move on to C. So be cautious. If you're asked to encrypt, you will go from this end to this end. If you're asked to decrypt, you will go from this point to this point. That is what you need to remember, and inshallah, you'll be able to get the final answer very accurately. So which method is easier? Which method is actually something that is more secure? Is definitely asymmetric encryption. So inshallah, you'll be able to manage this chapter number 2 very easily, and you'll be able to do it very well. Best of luck for your papers. Allah Hafiz.